Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to talk about a couple of scripts that I've had on my to-do list for probably years at this point. Now, these aren't what I would call complete, but at this point, I'm probably not going to finish them. I just don't have the time. There are also other tools that do some of these similar things. So what I wanted to do is just take a quick look at each of these scripts. I'm going to put a link in the description to the Patreon page where you can download these for free. And if you want to play around with them and add functionality to them and do whatever to them, then go ahead. Now, keep in mind, and I say this in every programming video, I am not a programmer. I don't have the knowledge of a programmer. And so a lot of times when I am trying to learn something like this, I go through the process of finding example codes, figuring out how they work, and putting them together. And so the code that we're going to look at will create mesh section sketches. And then I also have one that will go through and take solid bodies and create thin extrudes for those solid bodies to create like a topographic or a sort of stepped profile for them. So what we're going to do is we're going to run each of these scripts on some examples, and then I'll go through the scripts and kind of give you some pointers on where things are, what they do, and if you want to add to them or use them, play around with them, then feel free to do so. All right, so this first one, the main reason here is that if we are creating mesh section sketches, the way this works is we need to select a body, we need to select a section plane, and then what we're going to do is we're going to create a mesh section sketch. This is only a step in the process. We've done videos on this before. From here, what you need to do is then edit the sketch. And then inside here, you either need to use some of the automated tools like fit curves to mesh section, which for stuff like this, I always suggest against. If you reduce the tolerance to something fairly large, I think default it's 0.01. But if you reduce it to something fairly large, you can get a decent result for a spline. But in general, it's not a great result. And so if we take a look at the, for example, the curvature combs, you can see that there are some jagged sections here. And so in general, I will tell people don't use these. If you are going to create something like this, you would generally do it manually. So I would come in and do a control point spline. This is not going to snap to this. So this is one area where Fusion doesn't have the same functionality as something like Quick Surface. But basically what I would do is I would come in and I would create a curve to try to match the surface. And obviously you need to do some work to get it close. But if we take a look at the curvature combs of something like this, then it's going to be much smoother. This is what we would expect to see with a good quality surface. All right, and so that is, again, that's a portion of the process where we create mesh section sketches on a mesh. The problem is it is time consuming. And so the script that I came up with or that I built is something that'll speed up a portion of that process. And so first, I always like to have dialog boxes that pop up. I like a lot of feedback on what those programs are doing. So select two construction planes, bottom and top. So in this case, the XY plane and an offset plane. A quick note, if you're using this or the other script we're going to go over, the normal direction of the plane is important. So I tend to use the default planes. And for example, XY, the normal direction is in positive Z. If you happen to offset this the other direction, it's still going to build all the planes vertically in the wrong direction because it uses the normal direction based on the way that this program currently works. But then it tells us there's 155 millimeters between. Then it asks for the number of construction planes. You could also change this program to give it a distance instead of a number of planes. That could work also, but the way that I did it was just a number of planes. And so let's say that I want 10 planes here. I'll say OK. It says please select the mesh body. I also have it so that next to the cursor, it pops up and tells you what you're doing. So you can see the little tooltip says select mesh body. And then it goes through and it creates each one of these. Now, the trick with this program is the fact that this tool, Create Mesh Section Sketch, is not open to the API. And so the way that it works, at least in the program, is that we actually have to use some text commands to invoke what's happening on the screen. And you'll notice that the construction planes that are created are hidden with the exception of the first two that were visible to start with. And so that's another thing that you can toggle on and off. So let's take a quick look at this program here. So anytime we're working in these scripts, there are some things that are defined by default. So for example, I define the active document. It's showing up as gray and not white because it's actually never used in here. But a lot of times you'll have those things in the program where we may use this for something else, so it's just declared at the top. Sometimes they're in default programs. Again, you'll notice that importing Autodesk CAM, there's no CAM that's going on here, but I left it in there by default. Some of that stuff can get removed. But as we go through, I tried to add some comments in each of these sections. So for example, this section is all about getting the user to select the two planes. So the message box is what pops up, tells it to select the planes. Then it is a selected entity, and you'll notice there's also a note here, construction planes. This is the kind of thing that you see as a tooltip next to the cursor. Then it's going to store those planes. Anytime we have these brackets, it's essentially making this sort of array, and it's storing plane 1 and plane 2 inside of that array. We could call it back, so this would be the first entity, entity 0 in that array, and then this would be the second one. And then from here, you'll notice that we've got a section, I'm just going to move the cursor because the tooltips are annoying, a section where it's talking about measuring the distance. We have to remember that when we're talking about distances, that by default everything is in centimeters. This is true in Fusion, it's true in SolidWorks, it's true in pretty much every CAD package. And the sort of the units in the back end are centimeters. So when we're working in code, we need to convert that, which is why we're multiplying it here. We're multiplying these units to get that conversion. But again, the planes are saved in this array, so we call the first one, which is 0. Pretty much in code, everything starts at 0. And the second plane that we select is plane 1 inside of there. And it goes through and then gives a message box, and it tells you the distance. Then from here, it asks for the number of planes. And again, it goes through and we have to declare it as an integer, but then it asks us to enter the number of offset construction planes. And then it goes through again and it asks for the selection of the mesh body. And then it goes through and basically if you don't select anything, it'll say that nothing was selected. If you did, then it stores this as mesh 1 as the selected entity. So basically up here, we select the mesh body and it's stored as a selection, but then we actually need to declare it as something, which is the variable mesh 1. Now the next section here is where we start to create these offset planes. And so I put some notes up here that we call this function create mesh section, which is down here. We'll talk about that in a minute. And because all of the planes that are being generated also create the mesh section sketch as it goes, if we want them for the first plane and the second plane selected, we need to manually invoke that here. So we're invoking it with the selected mesh and then plane 1 and plane 2. Now there is a for loop that goes through based on the number of planes we defined. It creates those offset planes. Again, we need to use this 10 to convert from centimeters to millimeters. And then it'll go through and it'll basically append that list of offset planes. And again, so if we say that we want 10 planes, it'll be plane 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then as it goes through, it goes to this function, create mesh section, and it sends the selected mesh as well as the current offset plane that's being generated in this for loop. And so it catches it as it's being created. We could also come back, create the planes first, and then run through a for loop and then call each of those offset planes based on their ID number. In this case, it would be the variable I. And then the last thing that happens here is it turns the light bulb off. If you have been using Fusion long enough, you'll remember that up until about 2017 maybe, there was not an eyeball icon to turn things on and off. It was actually a light bulb. And so in the API, it's still called light bulb on. And then at the very end, it says the program is finished, just a message box. And so the call to this function, create mesh section, happens twice before the for loop, and then it happens each time running through the for loop. And so if you say you want 2 planes or you want 50 planes, it'll run through that 50 times. And each time it calls it, it accepts 2 arguments, a parameter for mesh and a parameter for a plane. And so in here, we have to define those as what they are, a mesh body and a construction plane. And then because this is a new section, we need to redefine things like the app, the user interface, and SELS or cells is selections, the active selection. And so essentially what we're doing is we are saying that the active selection is going to either be the plane or the mesh, depending on what we're doing. And so we go through, and again, because this section of the mesh is not exposed to the API, we have to go through executing text commands, which is looking at basically starting the command and navigating through the selection boxes in the dialog. And so as we go through, the first thing is the mesh. And so once we get to that section of the dialog and we enable it, which is the UI.enable command input, we then say that the selection is the mesh that we passed into this function. Then we sort of tab over to the next box, which is the plane selection, and then we say that the selection is the plane that we passed into this function. And then afterwards, the execute text command, this is essentially hitting the OK button. And so as it runs through, it does all of these things. And again, a fairly simplified example, but it's something that we have to do in order to get these mesh sections, simply based on the fact that these tools are not exposed to the API. And so basically, once we launch the command, it's looking for the mesh section. We push the selected mesh that we push into the function, then we sort of tab over to the next thing, we push the selected mesh. All right, so that's the first example. And again, I'm going to put both of these scripts in the description of the video. I'll leave a link to the Patreon. And again, it'll be free. You don't have to pay for it. But if you do add to it and make it better, if you are a programmer and you've got the skill and you want to share it, feel free to reach back out to me, support@caducator.com, and I can always update the code there and share it with people. All right, so the second example here is a tool that has a sort of similar function, but instead of just creating the section, what it's doing is it's actually extruding each profile up to the next plane. And so what we end up getting is we take a solid body in this case, and we generate that sort of stepped version of it. And there's two examples that I'm going to show you here of why we might use it. And so once again, I'm going to go through, this is called create sliced bodies. Select two construction planes, bottom, top. It tells me how far they are apart. It asks me how many planes we want. Again, you could change this up so that it has the millimeters of the distance, but I just chose to do it this way. You could also set this up so you only have one plane selection, but then I thought the two planes were kind of a good way to get the distance between. So let's do it fairly low, and let's say 10. Please select a solid body. We'll click that, and then it's going to go through and it says the program is finished. So what actually happened was it took the original solid body, and at each of these planes that gets created, which automatically get hidden, it is going to create a intersection sketch, and then it'll extrude that up to the next plane. And so this looks like a pretty, it kind of looks like a camshaft actually, but a pretty low sort of resolution version of that. Now, if we take this back and we run it again, let's go ahead and run it with maybe a higher number. So let's just say 50. So select the solid body, it's going to go through. One thing I've noticed with this code is as the number increases, so for example, 60 to 100, sometimes it'll prompt me with a warning, but it'll still run. I'm not exactly sure why, but if you run into that, maybe you can do a little digging. And so here you can see this looks a little bit more accurate relative to what we have here. And so once again, this has some applications for sort of artistic features, but in reality, what you could do is then create some keyed features like a square extrude that goes through it or sweeps through it that you could use to line these parts up. And then that would allow you to create all of these pieces as flat. If you're doing laser cutting or if you've got a wood router or something like that, you can build up these complex 3D shapes. Now, this has some applications in art, of course, as we're kind of looking at this, but it also has some applications for creating things like bucks or forms out of, let's say 1-inch thick pieces of insulation foam for a concept car body. Right, so if you've got a solid body or a solid version of that body, then you could use this technique to create 1-inch sections, and then you could route them out and build sort of the 3D shape and then sand it by hand. So let's take a look at a second example of where this might come in handy. And so this is just a topographical map that I made using forms. Again, select two construction planes, 68 millimeters, let's say 25. Please select the solid body. Click it, and then it goes. Now, the problem with this is that because we've got all these different peaks and valleys, now here's where it's going to give me an error. In this case, Let's see what it says. Intersect with sketch plane returns self entities. So it's saying that there is a projection that would result in a degenerate section. So I'm not exactly sure what that means. It still produces the model. And so that would take, again, some digging to figure out. Now, the problem with this, in reality, I'm not sure what that body is. This is probably the one that caused the error there. I'm going to just hide it for now, which is going to leave a section here. But the problem with this is that when we've got these sort of closed regions, it doesn't really know that, and I'm just hitting V on the keyboard, which is changing the visibility or hiding. It doesn't know that these should not be extruded. And I don't really have a good way to figure that out. So it just takes a little manual work where you have to sort of hide those. Now, that one sort of weird section, I'm not really sure what happened to it, but in general, you can see that this has some benefit in creating this sort of topographic map style of model from just a single solid body and creating these planes. Once again, it's not perfect. There are problems with it. There are some things that need to be improved. But once again, these have kind of been on a back burner list for me for quite some time. And every once in a while, I get a sort of a bug and I start messing with them, and then they kind of sit for another couple months. So I wanted to at least, make a video, kind of show where they're at, and then just give them out to the community so that y'all can work with them and play with them and maybe create something that is helpful out of them. So let's take a quick look at the sliced body. There's a lot of stuff that I've left in here. And I always try to leave comments in here, kind of remind myself as to what's going on. The first part of this program is very similar to the mesh section. Again, we're selecting two planes. We're creating a number of planes between them. And then the big difference is here that when we're selecting the solid body, there's some extra code that I've got in here. And so for example, to select a solid body, there is an extra bit of code in here that shows a message with the sort of entity selected, and it'll tell you whether or not that is an actual solid body, if it's a B-rep. And so I commented all this out because I don't really need to do a validity check for when I use this, but I did leave it just in case it was important. And so again, you can comment this stuff out by getting rid of that, and you can see that here, if the solid body is in fact a B-rep, then it'll prompt you and say valid. If it's not, then it'll say please select a valid solid body. So it's a bit of error checking that can happen. Again, I commented it all out because I didn't really need it. The next section here is where it's creating the first extrusion from plane one. Again, because that first plane is not part of the for loop that happens with all the new planes, then what is actually happening here is we need to create that extrusion from the first one if we want to use it. I have seen some code online that uses a line to generate planes along a path instead of doing it this way. That could be another method that you use, so that way the sketch could be created within the loop, because the first plane would be created at the 0 position on the line, the last one at the 1 position, and then you can sort of iterate in between based on the number you give it. A section here that I left in. So this is a part that will actually go through and add multiple solid bodies as opposed to manually selecting. I also did originally create this and play around with it for surface bodies and creating intersections. That obviously is a little bit complicated for things like the extrudes. So you can't really have a solid extrude from an open profile. You could do a thin extrude potentially, but there was just a whole lot of problems with that. But originally when I created this, it was for that. The next thing here is very similar to, again, the mesh one where we're intersecting with the sketch plane. However, in this case, it's code. This intersect with sketch plane is available to the API, so we don't have to do any weird text command tricks. We can just simply use that command intersect with sketch plane, and it's using the solid body, which is the selection up here. Now, you'll notice that this is in brackets. This is how it wants it inside of this call. It needs to be in this sort of range. I am only selecting a single solid body, but again, there's sort of room here to include multiples. From down here, there is a profile. And so what happens here is this creates a profile, the selected item a 0 here. And this is basically taking a look at the first section and it's working with it as a single profile. And so the 0 indicates that it's the first closed profile. If your first section actually had multiple profiles, so if there was more than one closed profile, this gets a bit tricky. But this, in my case, most of them are going to have a solid base, and then it can go up and sort of span off from there. So I just used 0 here, which again indicates the first closed profile. The distance gets calculated again from the input from the user, the number of planes, which is right here. And then you can see again, it's divided by 10, again, to get from centimeters back to millimeters. And then extrudes based on the profile. And again, the profile is automatically captured based on this, this command intersect with sketch. And then it creates a new body. You could also have these all joined together if you wanted to. Instead of new body, you could say join. It really just depends. You could also open that up as an option for the user in the dialog. And then from here, we've got a loop that goes through and generates all the planes, and then it does something with it. This is where I left a lot of extra code in, and if you want, again, you can uncomment some of this stuff. This section here, again, is looking at intersections with all of the bodies. So if you don't have the user manually select a body, this would go through and select all the bodies. I don't think that's a very good, robust way to do it. Instead, I decided to just have it a single manual selection from the user. But again, I left the code in here just in case. From there, again, intersects with the sketch plane. And then there is this section for extruding the profiles. Here is where I left some extra code in. The stuff up here, so this profile and extrudes, again, this is using 0, which is only going to select a single profile. If the sketch has multiple profiles, it will ignore. I don't know how it calculates which one is considered the first profile or not, but that is what this does. So if you have something that just has a single closed profile, like our first example, that would work fine. If you had something like the topographic map, that is not going to work as well. And so in order to handle that, there is a list here, so essentially an array. This list is going to contain all the extrusions, and then if there are multiple profiles, this for loop will go through all the profiles in sketch profiles. It should select each one, and each time it'll append the extrude, and it will create that new body. And so I don't know that it's a perfect solution, but once again, this got me to the point where it worked for what I was trying to do at the time. There are certainly improvements that can happen to make this a better solution. But if we look down in the timeline, you'll notice here, it creates a plane, it creates an extrusion, or a sketch, I'm sorry, and you can see there's multiple profiles here. And then it creates an extrude for each of those profiles inside of that for loop. And then once it's gotten all of the profiles, it moves on to the next plane up, creates a sketch. It says, hey, there's a bunch of profiles here, and it creates an individual extrude for each of them. It would be nice if all of the profiles were selected and extruded, and maybe that is possible to do in the loop, but that's just not how I built it out. So that could be another improvement there. But once again, there's not really a good way to tell it to omit some of these that should be negative. There's probably a way to do some checking against the original body. If you could do something like check an overlap, or if you use the interference detection, I don't know how well that is going to work because of how the naming conventions between the bodies. They should be sort of incremented, body 1, 2, 3, 4, 5, but I don't know that there's any sort of standard to what is going to happen with there. So once again, neither one of these scripts are perfect. Each one has some additional work that probably needs to happen. They do have some value in speeding up these workflows right now, just using them as is, but it certainly could be better. So if you're somebody that's looking into learning or playing around with API and you want to continue to add to these or make adjustments or play around with them, or just try them out. Again, I'll leave a link in the description so you can go download them and use them and play around. If you haven't used scripts before, we do have a playlist talking about getting started with it with some basic Python and some basic scripting that happens. So we've done several things from using scripts and add-ins, dialog boxes, communicating with the user, getting things like user parameters, setting user parameters, and even importing things like a CSV list and then generating a model off of that. So we've got lots of videos on all that. I'll leave that playlist in the description as well. But just at a basic level, there is a folder on your computer, and what you can do is you can go to that file location where these are saved, and you can just save the script that I put in the description in that location, and it should pop up for you. If you have any questions on this, please let me know. Once again, I am not a programmer, full disclaimer there. I do my best with this stuff, but there is plenty that I don't know or understand. I do enjoy learning, and if I had more time, I would spend a lot more time working through this. But I think that these are at a point where I can share them and you all can at least play around with them and hopefully get some benefit or function out of them. But once again, if you have any questions, let me know. As always, thanks for watching, and we'll see you in the next one.